A ship can sail at 20 knots in still water. There is a current of 5 knots on a bearing of 330 degrees. Opie sets course due east. What is his resultant speed and on what bearing does he travel? So let's look first of all at what Opie does. He is setting a course due east. Now we know in still water the ship can go at 20 knots, so this is 20. And remember, north is in this direction here. Then we have the current. The current is on a bearing of 330. So north is here. 330 is going to be 30 degrees to the left of that. So that's going to be like that. And we know that this is 5. And this angle here is 30 degrees. So what he actually does is the third side of the triangle. So this is his resultant speed. And if we can find this angle, then we'll have the direction, the bearing of his travel as well. Well, we know that this angle just here is 60 degrees because this was east and that's north. If that's 30, this must be 60. So we can use the cosine rule. So r squared would be 20 squared plus 5 squared. Take away 2 multiplied by 20 multiplied by 5 multiplied by cos 60 degrees. So we can calculate that. So we'll just clear everything. And what do we have? We've got 20 squared plus 5 squared. Take away 2 multiplied by 20 multiplied by 5 multiplied by the cosine of 60, and that gives me 325, and of course we want the square root of that. So square root of the last answer is, let's say, 18.0. So we'll say r is equal to the square root of 325, which is approximately 18.0, and that would be in knots. So we know this side now is the 18.02 and so on. And we want to find theta. Well, we can use the sine rule for that. So sine theta divided by 5, that's opposite the theta, would be equal to sine 60 divided by our previous answer, which we could do exactly as root 325. That would be the sensible thing. So sine theta is going to be 5 times sine 60 over root 325. So we can find theta. So theta is going to be the inverse sine of 5 multiplied by sine 60, and we'll divide that by the square root of 325, and that gives me 13.9 degrees, or approximately, we'll say 14 degrees, because with bearings we usually give it to the nearest whole number anyway. And so the bearing, well, this would be a bearing of 090, so we need to take 14 off of that. So that's going to be 076 degrees. Now in part B, we're told that OP must actually travel due east. In other words, we need his actual resultant to be due east, like so. Now, in order to achieve that, if he has a current running this way, so the current is at 5, he's going to have to steer down in this direction. So this is what he's steering, so this one is going to be the 20. Now we know that north is up this way, so what we really want to be able to work out is this angle here, which we can then add to 90 to get the bearing. Now what angles do we actually know here? Well, we know that this is on a bearing of 330, so therefore this angle here in here is 30 degrees. So if I do an angle across there, this one here would be 60 degrees. And then we've got these parallel lines here. So if this one's 60, this one must be 120 degrees. So we have enough information. So we can use the sine rule. Sine of phi divided by 5 would be equal to sine of 120 divided by 20. So sine phi would be 5 times the sine of 120 divided by 20. So our angle phi is going to be the inverse sine of 5 multiplied by sine 120 and divide that by 20, and that would give us 12.5 degrees. So just because we give the bearings to the nearest whole number, we'll call that 13, and so the bearing would be 90 plus that, so 103 degrees.